Hi everybody, today we're going to learn about molarity, and to define molarity we need to understand that molarity is a word that is trying to describe how concentrated our solution is. So in other words, how many moles of a solute are there in a liter of solution. You're going to want to be taking notes as we go along here. So as you take your notes, keep in mind that these notes are for you, and you are not going to be taking pictures of your notes to show me what your notes look like. Instead, there are going to be some questions at the end of this presentation for you to answer in an Edpuzzle format so that you can tell me what your answers are in that format. Okay, so let's get started. Our formulas today are going to be for molarity. It's going to be moles over liters. And that's given in words here, and it's given in symbols here. Do you notice that we have a capital M for molarity? And that is because we use a lowercase m for mass, and so we are not going to capitalize the mass. We capitalize M for molarity. We might also need to remember that moles can be calculated by taking our grams and dividing it by our molar mass. So you're going to see reference to molar mass in these problems, and that is because you're going to need to take the number of grams and divide it by the molar mass to be able to get the correct number of moles. We also have an equation here for dilution. And dilution is a term that is trying to describe how much water should be added to reduce the overall molarity down to a certain level. That's one way of looking at it. Or how much, what the new molarity will be if we increase the volume of a solution by a certain amount. So you'll see that that equation is original molarity, M1, times original volume, V1, equals new molarity, M2, times new volume, V2. Okay, so we're going to see about how to do all of these sorts of calculations. So let's get started. All right, so our first example says if a beaker containing 4.0 molar solution goes from 35 milliliters to 65 milliliters, what is the new concentration? First thing we have to ask ourselves is, well, which formula are we going to use? And so let's take a look at what our variables are that will help us be able to determine which formula to use. So in this problem, I'm given a molarity, an original molarity. I don't know the new molarity. I'm given an original volume, and I'm given a new volume, which means that I should be using my dilution equation. So that's exactly what we're going to do. We're going to use our dilution equation because we have an M1, a V1, and a V2, and we're solving for M2. So we're going to plug in our numbers, and we are going to follow our mathematical steps that you can see there to solve for the new molarity, which in this case comes out to 2.2 molar. Remember, everybody, you should be stopping the video and taking notes as we go along. Our second example says, what is the molarity of a solution containing 5.0 moles of potassium hydroxide in 300.0 milliliters of solution? And we also have to ask ourselves again, which formula do we use? So in this case, we're going to list down our variables, and we want to know what is the molarity. We are given moles and we are given liters. So that means that we have moles over liters that we are going to be using in this example. So we will use molarity is equal to moles over liters, and we're going to plug in the numbers that we have, and we are going to solve for the new molarity. Now some of you might be asking, well, hold on, wait a minute, how did we get from 300 milliliters to 0.3000 liters? And what we did, everybody, is we divided our 300 milliliters by 1,000 to convert from milliliters to liters. And so please remember, that should be part of your notes as well, that to convert from milliliters to liters, liters is equal to milliliters divided by 1,000. Boy, my handwriting with this mouse gets worse and worse every time I do it. Okay, so remember, pause the video, write down the notes that you need to write down, and we will continue. All right, our last example says a solution contains 350 grams of calcium chloride and 5.0 liters of water. What is the molarity of this solution? This time we are given a molar mass of the calcium chloride is 110.98 grams. We have to ask ourselves again, which formula do we use? Do you notice that we have grams in this formula and we have molar mass? This should be making you think, aha, I have to calculate moles. So calculating moles, given liters, I'm going to solve for molarity, and so my equation I'm going to use is molarity is equal to moles over liters. Plugging in my numbers and solving by division, I'm going to get molarity is equal to 0.63 capital M. Okay. All right, now why is this also important? Because what we have in a solution is a bunch of dissolved particles. Sometimes a solution can be called an electrolyte if that solution has particles that are charged in it. In other words, ionic compounds produce charged particles, but covalent compounds only have non-charged particles. So you'll notice that a light bulb, which shows us conductivity, will light up if there are particles with positives and negatives on them, like which comes from an ionic compound, but a solution that only has covalent compounds in it does not have any charges, so it will not make the light bulb light. Okay? You might be going, okay, now wait a minute, I have heard this term electrolyte in the past. Don't I have electrolytes in me? And don't I feel bad if I sweat too much and I lose my electrolytes? And the answer is yes, you do. So let's talk about why that is. So when you are sweating and working out and trying to be healthy, your body uses electrolytes. Electrolytes go into your cells and helps you stay healthy by helping you carry electrical impulses for your nerves and muscles. If you get low on your electrolytes, in other words, you become dehydrated, your electrolytes are not in your cells and you are not able to do as well with using those electrical impulses for nerves and muscles. So you need to replace your electrolytes. That's why they sell products like Gatorade, which have electrolytes in them. Okay, so it's all about the conductivity of solutions, even inside the Gatorade that we are drinking. Okay, so for your work for this topic, you are going to be completing several questions in the Edpuzzle format. If you are unable to complete these several questions in the Edpuzzle format, then you can complete them on paper and submit them on paper. So you'll notice question 1, what is the molarity of a solution that contains 105.0 grams of sodium nitrate? So I'll let you do that one next. Question 2, what is the molarity of a solution containing 2.0 moles of potassium phosphate? We might need to help you remember that potassium phosphate is K3PO4, for those of you who don't remember what potassium phosphate is. Okay. Next, we're going to go on to question 3. If 700 milliliters of a 4.5 molar solution of NaBr, sodium bromide, is diluted to 2.0 molar, what is the final volume of the solution? Okay. Question 4. What is the molarity of a solution that contains 9.5 moles of calcium chloride in 4.00 liters of solution? Question 5. A student has 50 milliliters of a 3.2 molar solution of an acid. He adds water until he has 85 milliliters of the solution. What is the new concentration? Number 6. What is the molarity of a solution composed of 5.85 grams of potassium iodide dissolved in enough water to make 0.125 liters of solution. Molar mass of potassium iodide is given as 166.00 grams. All right, those are your 6.